Let's get started. So today we're doing 4-4 function operations. So function operations, we've already learned how to do it all. Now it's just applying it in function operation mode. An operation is performing something on functions like addition or subtraction, multiplication, division. They're all operations. So you can add, subtract, multiply, and divide functions based on how you perform these functions for real numbers. One difference, however, is that you must consider the domain of each function. So domain is what we can put into a function, correct? Domain is x values or input, right? We're going to have to restrict the domain on these according to what we can and can't have for real numbers, and we'll talk about that in a second. So guys, function, operation, addition. You're going to see it written like this now. So notice how it says f plus g of x. That's literally, you can split it apart, and that's the same thing as f of x plus g of x. And you're just adding two functions. Does everybody see how that's pretty easy? You can see it written both ways. They mean the same thing. So either way, you'll have the same thing. So this just meant you had a function f plus a function g, and they're both functions of x. So right here, f minus g of x, you could just split it apart, and that's the same thing as f of x minus g of x. Does everybody understand? And then same with f of x times g of x, f of x times g of x, f divided by g of x. That would be f of x divided by g of x, and then we know that the bottom cannot equal 0, correct? So in this particular instance, g of x cannot equal 0. Does everybody make sense of that? We can't divide by 0, right? So that's just one of the restrictions we'll have to make. Okay, so you'll perform the operation, then look at your new function, say, do I need to make any restrictions on our domain? Because we're going to be dealing with all real numbers. So let's just get right to it. Do we have any questions with this? Pretty straightforward, right? So here we go. Just look at these examples with me. You don't need to write them down if you don't want. Really, you don't. So we have f of x is 4x plus 7. G of x is the square root of x plus x. It's asking us what's f plus g, what's f minus g, and what are their domains. So we're really looking for f plus g of x, which we know that's just literally taking f of x plus g of x. So f of x is 4x plus 7. And we're adding g of x, which is the square root of x plus x, correct? So now we'll just simplify it. This is f plus g of x, so let's combine like terms. 4x plus x is 5x, right? Is everybody feeling okay about this? And then we have plus 7 and plus the square root of x, so I'm going to write plus square root of x plus 7. So I've combined all like terms here, correct? That is f of x plus g of x. That's our answer. So now we would have to look at this and say, okay, we need to restrict our domain. Maybe we'll come back to that because I wanted to talk about that first. And so we'll come back and restrict the domain in a second. So now let's do f minus g of x. So now we're doing f minus g. So that's f of x minus g of x. Now subtraction is just a red flag problem. Because remember, when subtracting polynomials, you've got to distribute the negative. So just make sure your algebra is all good here. Oh, I need to be able to see what f of x is. So f of x is 4x plus 7. Now we're subtracting all of g of x, so I'm going to put it in parentheses. So we have the square root of x plus x. Is everybody comfortable with that? I'm taking all of f of x, subtracting all of g of x. So now I'm going to go ahead and distribute, because I like to distribute that -1 through. So we really have 4x plus 7, and then we have minus the square root of x, and then we have minus x. I distributed my negatives. You just can't mess up when subtracting. So let's combine like terms. 4x minus x is 3x plus 7, and I'm going to actually write it in standard form, so highest degree to lowest degree. Why is this degree lower than this degree? Yeah. Good, it's to the 1/2 power. Very good. So minus square root of x plus 7. So that is f of x minus g of x. So I'm going to circle that because that's part of my answer, and then we're going to come back and restrict the domain in a second. Everybody good with this? Okay, let's do these two, and we'll come back and restrict our domains in a second. So here we go. It says, what's f of x times g of x? F divided by g. So f of x times g of x. So f of x is x squared minus 9. We're timesing by g of x, which is x plus 3. So you guys go ahead and do that. Pretty straightforward. Just do it on your whiteboard. And you tell me what we get. We get x cubed plus 3x squared minus 9x minus 27. Okay, awesome. There's our answer. And then let's do f divided by g of x. So f divided by g of x is literally just f of x divided by g of x. So f of x is x squared minus 9 divided by g of x, which is x plus 3. Everybody feeling good about that? Now, that is our answer unless it simplifies. Does it simplify? Yep. How do we simplify rationals? We just tested on this. We factor the top, right? So we have an x plus 3, x minus 3 on top. And on bottom, we have our x plus 3. And then we would simplify. So is our final answer going to be x minus 3? Okay, awesome. Okay, now let's talk about domains, restricting the domain. So with real numbers, so that's going to bring me to this. So this is probably the hardest part for students is actually restricting the domains correctly. So domain, we're dealing with real numbers in this unit. So there's there's a couple things we need to restrict. First of all, we do not have imaginary numbers in the real number line. Everybody knows that, right? So we're not going to be dealing with imaginary numbers. So we can't have something negative underneath an even root. Did everybody hear that? So we're going to make sure that we restrict our domain so that there's not a negative underneath a square root or a fourth root. Does everybody understand? So is it okay, though, to have the square root of 0? Yes. So underneath the radical can be 0. The square root of 0 is 0, which is in the real number line. Right, everybody? So we can have a 0 underneath the square root. It just can't be negative. So won't this thing underneath here need to be greater than or equal to 0? Larger than 0 or equal to 0, we'll make sure it's not negative. Does everybody understand that? The thing has to be greater than or equal to 0. Okay, so looking at this, if I had this as my final answer, we know that we can't have negatives underneath a radical. So we would say all x, our domain is what we can put into it or what x values are going to happen here. So won't these x values be the x values greater than or equal to 0? Everybody good? Okay, so looking at this one, we would say to ourselves, okay, underneath the radical, we cannot have a negative. So that thing underneath there, x minus 4 needs to be greater than or equal to 0, correct? Underneath the radical needs to be greater than or equal to 0. So now solve for x. What x values will that be? X values need to be greater than or equal to 4. Now think about why that works. 4 minus 4 is 0. 5 minus 4 is 1, so we're good. If we go less than that, 3 minus 4 is negative 1. So do you see how we're restricting the domain accordingly? Okay, awesome. Okay, so that would be one of our restrictions. And then another one is we can't divide any fractions by 0. So our denominator, we've got to say, cannot be 0. So in something like this, let's say this is a final answer. We would say, okay, the bottom can equal 0 of a fraction. So x cannot equal what for that piece? 2, and what for that piece? Negative 3. So the domain would be all real numbers except for 2 and negative 3. Does that make sense, everybody? Any other number works here if it's a real number. Questions on that? Okay, now we're going to restrict the domain. So like looking at this answer right here, is there any potential problems in this piece? No. What about right there? Yes, a potential problem. We can't have negatives underneath a radical. So that thing underneath there needs to be greater than or equal to 0. So all real numbers, as long as they're greater than or equal to 0. Yes. So we could do it in interval. You can see it 2 different ways. On the online homework, they'll ask you 2 different ways. So in interval notation, won't that be 0 to positive infinity? Right? And does it include 0 for this problem? Yes. So we could write the answer like that. That's our domain. 0 to positive infinity, including 0. Okay. So same thing here, right? The domain would be x values greater than or equal to 0. So we could write it as 0 to positive infinity. Any questions? Okay, looking at this one, I'll be right with you. Looking at this one, is there any potential problems? No, no fractions, no radicals. So we can plug in any real number. So we would say all real numbers would be our domain. Does everybody understand? Or negative infinity to positive infinity. And then same thing here. Wasn't this our answer? Oh crap, nope. I messed up just saying that. Don't we need to look right here? Isn't this technically, don't we need to restrict the domain before we simplify? Yeah. So we would say x cannot equal -3. So domain would be all real numbers except -3. That makes sense, everybody? Yeah. Or if they wanted you to write that in interval notation, let's think about how we would write that, okay? Because I'm afraid if I don't go over it on the online homework, they do it. So if it can be any number other than -3, can we have negative infinity up to -3? Does any of those numbers work up to -3? Okay, parentheses because we're not including -3 on this one. And then union, because our answer is going to have more to it. After -3, it works. So from -3 to positive infinity also works, but we can't include -3. So that would be in interval notation. Okay, sweet. Are you guys ready to practice a few? Okay, so what I'm going to have you do right now, because then we'll come back to this. Don't do those. Sorry, I got to figure out where I want to be. So you guys do this one on your whiteboard. This one. So what did you get? Oh, it's okay. You did multiplication? Oh, okay. Yeah. Let's see. Sweet. X squared minus 1 over x plus 1. You factor the top to be x minus 1, x plus 1. Then all over x plus 1. You restricted your domain. X cannot equal -1. And then you simplified. So it looks like most of you got it right. There's our answer. Our domain is all real numbers except for -1. We won't put it in interval notation because hopefully we know how to do that already. Good job, guys. Okay, go ahead and do this one on your whiteboard. You guys tell me, okay, so you did x squared plus 3x on top. On bottom, we have our x to the 4th plus 3x cubed plus 3x squared plus 9x. So then you'd say, I like what I'm seeing. You're all knowing I need to simplify this. And it was even excellent that you remembered that when you have 4 terms on bottom, we factor by grouping. So the top, we pull out an x. Left is x plus 3. On bottom, we're factoring by grouping. Those of you that remember that, way to go. If there's 4 terms, we try factoring by grouping. In common here is x cubed, right? Left is x plus 3. In common here is positive 3x. So then left would be x plus 3. Am I correct? We know it did factor by grouping because our safe haven's the same. So we factor out x cubed. Sorry. Well, we factor out x plus 3, but yeah, that's fine. X cubed plus 3x. Sorry, I was just looking back at my work. And then we still have, go away. Okay, and then left is x plus 3. Okay, I was loving what I was seeing because then you were realizing that that's not factored completely because we can pull out an x here, right? And left is x squared plus 3. You guys are so awesome, really. And then that's on bottom. Okay, let's write it. X squared plus 3, and x plus 3. Okay, now we've got to restrict our domain. So it's when the bottom equals 0, correct, would be a problem. So for this piece, x cannot equal 0. Okay, then for this piece, it's straightforward, -3. Now for this piece, I would say this. X squared plus 3 equals 0, solve for x. Subtract 3, x squared is equal to -3, square root both sides. Won't that be x is equal to plus and minus I squared to 3? Now we're not dealing with imaginary numbers, so this restriction is not needed. Does that make sense, everybody? So that's good that we did that, but then we just say we don't need that because we're dealing with the real numbers anyways. So those are our only 2 restrictions because we're not going to be putting in I. So our domain will be all real numbers except 0 and -3. Yeah, we can talk about interval notation with that. So you guys, how would you think we would do it? Yeah? Correct? Okay. Okay. Oh, okay. I like that idea. Okay. Dylan, this is answering your question, dude. Then 0, comma. Okay, almost. So aren't we okay with numbers between -3 and 0 as well?
You have to do -3 and 0.
Okay, so we're going to have another union here, right? We can have numbers between between -3 up to 0 as well. -3 up to 0 is okay as well. Just not including those. Really good, Amelia. Really good, Dylan. Good fix on both of those. Okay, awesome. That would be interval notation. So we'd have another union there. Now we can simplify that and that divide out, that and that divide out. So our answer is 1 over x squared plus 3. There's our domain. Everybody good? Okay, good job. What time is it? Yeah, we have time for this one. Yeah, do this one. Okay, so this first one, it looks like nobody had issues with. 2x f of x times the square root of x minus 1. So we would distribute, so that's 2x square roots of x, and then this times this, which is negative 2x. Okay, understand, that answer is completely fine. But let's say it was a multiple choice test and you did not see that. What's another way we could simplify this piece? Didn't we just learn that that's really 2x times x to the 1/2? Guys? Right? So this answer is acceptable, but also you could have 2x to the, when you multiply the same base, you add your exponents, isn't that 3/2? Minus 2x. So if you would have saw that answer in multiple choice, would you have been able to get there? Hopefully, yes. Okay, so this answer is fine. For right now, I mean, that's fine, because one's not considered technically really a whole lot more simplified than the other. So x has got to be what? Greater than or equal to 0 because of that piece right there. That's the only potential problem. All real numbers that are greater than 0 or equal to 0. 0 to infinity, right? Okay, number 11 was a teeny bit harder. Here we go. We did f of x, which is 2x, over g of x, square root of x minus 1. Then I like that I'm seeing you guys think advancedly. You really are doing awesome. It's saying, I know that that's considered not simplified because I can't have a radical on the bottom of my fraction. Then you were even awesome to remember we just learned how to get rid of something when there's two terms and it has a radical. The conjugate, right? So parentheses, parentheses. So here we go. Okay. So Chip, I think I lied to you. So let's multiply this out here. So we have 2x square roots of x plus 2x, right?
Yep.
Is everybody good with that? You guys were kind of treating it like it was this, I think. Yeah. Oh, you did do that. Okay, awesome. And then all over what? X minus 1 when we double distribute. Okay, so now we'd say where are the potential problems? Well, first of all, we can't divide by 0. So x cannot equal 1. And then there's another potential problem. X has got to be greater than or equal to 0, correct? So see if you can tell me before lunch, and then when we come back, we'll just keep going. Tell me how you could write that in interval notation. Think about it for a second. I'm seeing good things. So here's one thing that we just can't forget. Can't we have 0? So we got to put a bracket. 0 to 1 union, and then 1 to infinity, not including 1. Good job. Those of you that got it, yeah, awesome. Those of you that tried, good. Okay, go to lunch. Perfect timing. So I didn't really realize that you guys have already learned this. So that means we can kind of fly through this. That's great. So, well, they said, other people said they learned this last year.
Last year?
I heard that from other teachers. Well, some people in this class said that, but then other teachers did tell me, now that I think about it, the other teacher, aka Mr. Roberts, told me you guys should have learned it. But it doesn't matter. Here we go. I'm going to teach it to you anyways. So function composition. This is a function operation just like addition, subtraction, multiplication, and division. It's just a little different. So the composition of functions, g with function f, is written as GOF. Now, I always say GOF. That's fine. You can say it GOF, but it's really read C composed of f. Does that make sense, everybody? So that open O is not a times sign. It's a It means composed. So GOF is defined as this. So if we have G composed of f of x, we can rewrite it as, I like to say, this is how I rewrite it correctly. Picture yourself grabbing x and smushing it back in with f and then smushing it back in one more time. That's G of f of x. So G of f of x is G of f of x. Now, we know how to do G of 2. Don't you just plug in a 2 wherever there's an x into function G. So we should know how to do G of f of x. Plug in function f of x wherever there's an x into the function. So now you're composing function G with function f. Does that make kind of sense? Okay. All right, so let's just do it. Okay, so given h of x is equal to x squared and g of x is equal to 2x plus 3, we're going to find h of g of x. That's h composed of g of x. So I like to smush it back in. So x smushed back in with g is g of x. Smush it back in one more time. That's h of g of x. Now it's easy for me because we know we're going to always substitute what's inside our parentheses. We're plugging in g of x into the other function wherever there's an x. So watch. Locate g of x. We're plugging that into the function h of x wherever there's an x. Not multiplication. You're replacing it. Just like if it was h of 2, you put a 2 squared, right? Okay, so that's what we're doing. So we have parentheses. Anytime we make a substitution, we'll use parentheses. So we're plugging that in wherever there's an x. So we have 2x plus 3 squared. You see how we replaced x with g of x. We just composed function h of function g. Now we could simplify that. So that's 2x plus 3 times 2x plus 3, which is 4x squared plus 12x plus 9. And domain is all real numbers, correct? No problem areas. Okay, questions? Okay, let's do GOH of x. GOH of x, once again, picture yourself grabbing x, smushing it back in with h. That's h of x, smush it back in one more time. G of h of x. So we're putting in h of x this time into the function g wherever there's an x. It replaces it. Do not do multiplication. So that is 2 times, not x. We're replacing x with that function, x squared, right? Any confusion here? Plus 3, because this is like really hard for regular students to grasp, so I can't tell if you're grasping it or not. Like, are we? Yes, I would love to say it again. So we take h of x, and we're putting it into function g wherever there's an x. So see how I replaced that with this function. 2, instead of x, we're plugging in this function. Does that make sense? Just like if it was g of 2, don't you do 2 times 2? So we're doing, instead of g of 2, we're doing g of h of x. So it's 2 times x squared. Okay, so then our final answer would be simplified. We know that's just 2x squared plus 3. And then domain is all real numbers. Any questions on that? All feeling okay? Okay. So let's do this one. So there's 2 different ways to do this. So notice we're given f of x and g of x, and it says what's GOF of negative 3. So instead of x, we're doing negative 3. There's 2 different ways you could do this. What I'm going to do first is this way. We know that GOF of x is really g of f of x, right? Now you say, which one am I substituting in? We're always plugging in what's inside our parentheses here. So locate f of x. We're plugging it into function g wherever there's an x, right? So we're going to have x minus 5 squared, correct? So now we would, instead of, so that's g of f of x. And now we don't want g of f of x. We want g of f of negative 3. Does everybody understand? So instead of an x, there's a negative 3. So now that we found g of f of x, we'll just plug in negative 3. Does everybody understand? So that would be negative 3 minus 5 squared, which is negative 8 squared, 64. That was the hardest way to do it. Here's an easier way. So, same answer, let's hope. We've done something wrong, so just kidding. I know it's going to be the same answer. So g of f of -3. Just right off the bat, say I'm going to squish that back in with that. So that's f of -3. Squish it back in one more time. So we're doing g of f of -3. So what I would do is say I'm going to simplify that first. Can't we plug? Don't we know easily how to find f of -3? Plug it into function f. So won't that be -3 minus 5, which is -8? So we're really just doing g of -8. So we simplified it from the inside out. So now we're plugging in -8 into g, which is -8 squared, which is 64. That's the easiest way when calculating an actual value. Just simplify the inside and then keep simplifying. Pretty easy? Okay, let's do these two. Actually, I'll let you go for them. 5 and 6. Okay. So on the first one, you rewrote it as h of g of -5, hopefully. Did you rewrite it like that? Yeah. And then you calculated that, and what'd you get? What's g of -5? -10, guys. So now we know h of -10 is simply plugging in that into function h. Is everybody good with that? So that's 104. Okay, next one. It says find f of g of a. So that's f of g of a. So I just did g of a into g of x into f of x. So because we know we're substituting in this, you can do it. You can think of it a few different ways. You can say what's g of a. So that would be a minus 3, right? And then plug that into function f. So we'll plug that in there wherever there's an x. So that'll be a minus 3 squared. That's an acceptable answer. You could multiply it out, also acceptable. Any questions? Okay. Okay. What I want you to do is this one. On your whiteboard, do this one. Good, you guys are awesome. You plugged in f of g of x. And so you plug this in here, which you all got it. Minus x squared. I'm just making sure that the video is good to go. Squared. So then that and that cancel out. 9 minus x squared minus 9. So you guys got -x squared. No domain restrictions, right? Okay, awesome. Okay, how about, let's see here. I'm trying to decide where to go. Okay, let's go to this piece. Here is a real world problem, and it's actually easier than it looks, so let's go through it. It says, you have a coupon, do you guys say coupon or coupon? Coupon. Okay. You have a coupon good for $5 off the price of any large pizza. You also get 10% discount on any pizza if you show your student ID. How much more would you pay for a large pizza if the cashier applies the coupon first? So this is what we're going to do. So X is going to be the cost of a pizza, correct? Okay. So that's what I'm going to start out with. I'm going to say X is the cost of a pizza. It says you have a coupon for $5 off the price of any large pizza. So I'm going to write a function for that. Cost of a pizza with the coupon. So I'm going to call it C of X because that's coupon of X. I know, just C of X. And that would be $5 off the total cost. So won't that be X minus $5? Everybody good with that? This next part tends to get people. You also get a 10% discount on any pizza if you show your student ID. So let's do like student ID. So I'm going to do I, a function of I. So what would be a function for that? Let's pretend like you don't have the $5 off. You only get the 10% discount. Yes. Almost. So X times 0.10 is what we want to do. But we have to think of it a little backwards. Here's why. Because aren't we paying 90% of that pizza? Does that make sense, everybody? So we've got to take the cost, and we're only going to be paying 90% of that. So 0.90. Does that make sense, everybody? I used to do it backwards all the time. Okay. So that's the worksheet. Watch the video lesson for it. Okay. So now it says, how much would you pay for a large pizza if the cashier applies the coupon first? So think about that, guys. Function composition is when you apply one thing and then put it into the other. So that would be applying the coupon first. That would be this first, correct? So that would need to be inside. So we're talking C of x first, and then I. I of C of x. Does everybody understand? Just like f of g of x. So then that would be what? This into this, wouldn't it? So that would be x minus $5, replacing that x, times 0.90. So now you could actually, okay, so it says how much more will you pay for a large pizza as a cashier apply for coupon first? There's a couple different ways we could do this. Let's just do it the easy way. Let's pretend like the pizza costs $5. Couldn't we calculate it this way, calculate it the other way, and then look at the difference in money? Do you get what I'm saying? Yeah. Okay, so let's do it the other way while we're here, though. If we were to apply the, what was it called? The ID first, the ID discount, that would be I of x of C of I of x. And that would be what? Yeah, you could. Plug that into there, right? So won't that be, plug this in there, right? So that would be x times 0.90 and then minus 5. Do you get what I'm doing here? Yeah. Okay, so I personally, you could actually simplify that and subtract them to see the difference, but I think that's harder. So I'm just going to plug in $10. Let's say it costs $10 and then calculate the difference. So let's do that. Go. Let's say that it's $10. Plug in a 10, calculate that. Plug in a 10, calculate that. 5 times 0.90. Tell me what it is. 4.5. So this we were paying $4.50. Okay? It's a big discount. And does that make sense? $5 off. That is a lot off of a $10 pizza, right? So it is making sense, our answer here. Just how much is, what's the difference between the two? I think it's set, the question. Is that what you're asking me?
No, what is
Oh, if I plugged in $10. Yeah, so they paid $4.50.
Oh.
That's the cost that they'll be paying. What was this one? $4. Okay, so this is what you'd say. When we took so what's better? You would rather them do this first, right? Everybody, because then you're only paying $4. So it does matter, because I've actually had this happen in like a real world situation. I went to a store called Christensen's in Richfield, and there was these 2 discounts, and then they were like, I heard them talking to each other, like, which one do we put first, the 20% discount or the 10% discount? And the one girl's like, it won't matter, it's the same either way. It matters. So then I'm like over there, give me a pencil. I'm like, excuse me, miss, can you change your mind and do the other one first? And then they were like blown away by this. Like, they were like, oh, whoa. So then they had to go get the manager to see, because I was getting such a good, a good deal. And he's like, well, I never really thought about that myself. I'm like, okay, well, sir, you can hire me and pay me a lot of money to think about those things for you. Okay, so we would say the ID was better, and better by 50 cents. I don't remember what the question was. How much more would you pay 50 cents? That was the answer.
For a large pizza.
For a large pizza. Okay, awesome. Okay, I think we're good. So what I'm going to have you do is do this one. Okay, so let's talk about this first one. This one was a little bit easier, but I'm a little bit worried that maybe some of our algebra is not right. So let's talk about this. Okay, so looking at this, we know this is f of g of x, so we're substituting in g of x into f. So that would be this one, and we're plugging it in wherever there's an x, right? So we have the cube root of, replace that x, we have x cubed plus 1, right? Then don't we have our minus 1? Okay, so yes, this is, I had somebody ask their neighbor, is this multiplication? No, it's not, right? It's subtraction. So we have, now we can simplify underneath the root here. Those parentheses don't matter now that we're just dealing with subtraction. So that's just the cube root of x cubed, which I think all of you said x. Very good. That is correct. So we got that one right. Let's check this next one. G of f of x, so that would be the other way, taking this, plugging it in here, wherever there's an x. So that is, oh yeah, good. You have the cube root of x minus 1 cubed plus 1. Very good. Root and power cancel out. So we have x minus 1 plus 1, which is x. Very good. There are lots of times when those come out the same, but that's not always true. Does that make sense, everybody? Okay, awesome. Okay, FOF of x. This is a lot easier than it looks. You're plugging function f back into f. Does everybody get that part? So it's that plugged back into itself. So what would that be? Cube root of x plus 1 cube root of x minus 1, and then minus 1 like that. Is everybody seeing it? Okay, now let's think about this simplification-wise. I'm kind of going yikes. Simplification-wise, this is out of the pre-calculus book though. Simplification-wise, let's think smartly about this. Technically, that is, this stays the same, cube root of x minus 1 cubed, correct? Not cubed, sorry. 1/3. Isn't roots writing it as a rational exponent? You see how I rewrote it? The reason I do that is because I want you to think about it. Is it okay to just raise that to 1/3, raise that to 1/3? No, subtraction. Just like if that was squared, we know we can't just square that. Right, everybody? So, I believe, I'm just looking at this. Depending on how far they want us to go here, we could rewrite it. The thing is, I'm just trying to make sure that I'm correct in thinking we can't simplify that. But algebraically, we can't do that. We know that. That would not work. So I'm going to think about this one for a little bit longer, but I think that this would actually be considered like the most simplified answer. Because we aren't breaking any mathematical rules here. Does that make sense, everybody? If you did just cube root that, you'd be absolutely wrong. We can't do that. Okay. So I'm going to come think about that one, look at my book, and make sure that I'm right. Okay, awesome. So how about we do all of those? Okay, so f plus g of x, so that's the square root of x squared minus 4, both under the root, plus x squared over x plus 1. Now let's say that, that's a great answer, but let's see if we can get a common denominator, thinking smartly here. So this is over 1, so now we need to multiply by x plus 1 over x plus 1. There's two terms, I better put parentheses here. So now we're going to multiply this through. X times that is just x square roots of x squared minus 4, right? 1 times that is that. So plus the square root of x squared minus 4. And then we have on top plus x squared all over the common denominator of x plus 1. So we have combined all like terms on top, right? So this would be our answer. Nothing more we can do here. That's not the same as that because of the x. So then restricting the domain, x, this restriction's a little bit tricky. X cannot equal -1, right? And then that's got to be greater than or equal to 0. So x squared minus 4 has got to be greater than or equal to 0. So we would add 4. X squared has got to be greater than or equal to 4, right? X has got to be greater than or equal to... Wouldn't it be plus and minus 2? Greater than -2 and greater than 2. So it's just greater than 2, right?
So what about -1, 0?
Greater than, it's got to be also greater than 2. I don't know, I'm trying to think. So let's think about this. If x needs to be greater than or equal to -2, and x needs to be greater than or equal to 2, wouldn't this account for the -2?
Yeah.
So I think we just go with that one.
So what about your?
Oh, you're right, because, well, if we plug in 0, we'd have a negative, which is a problem, right? That's why it's got to be greater than 2. Does that make sense, everybody? And then think about it. It cannot equal -1. We don't even need that answer because we know that x values have to be greater than or equal to 2.
Okay.
Because -1 is already, we've already taken care of. It's definitely not going to equal -1 in that restriction. Okay. All right, so that took up all my whiteboard space. Were you guys able to do a few more of those? No? You want to keep trying, keep going? So you want a different one?
I'll do it.
Okay, do this one.
Oh, you multiply by constant?
No, we don't multiply this one by the conjugate, right?
How do you know?
Because that's the square root of 1 minus x. There's not 2 terms. That's like 1 term. I mean, there's 2 terms under the radical, but it won't take care of it correctly for us. So you should get this. Do we get this?
Yeah, I did. Then I said, hold on.
Same, so you rewrote it as -x plus 1, then you factored out a negative. Okay, so yeah, we could just leave it like this or do that. Either way, same thing. So x cannot equal 1, correct? Because then the bottom would be 0. And then look underneath. This has got to be greater than or equal to 0. So 1 minus x has got to be greater than or equal to 0. So let's solve for x. Subtract 1, correct? Okay, so we have -x is greater than or equal to -1. What would we do next? Divide by -1. Didn't we just divide an inequality by a negative? Flip your sign. So x is less than or equal to 1, correct? Now we're going to take off that equal sign because we know it can't equal 1. Does that make sense, everybody? So just x has got to be less than 1 because it can't equal 1. We take that part off the inequality. So x value is less than 1. So our interval notation, which is most likely what you're going to have to write it, is -infinity up to 1, not including 1, right? X values less than 1 would be -infinity up to 1, not including 1. So we all understand, because we're going to have to do the online homework. Yeah. Because see that minus sign, it's going to change all our negatives to positives. Does that make sense? So it just happens to work out algebraically resolved, and then it makes sense because of the negative. Otherwise, if we plug in +5, that's going to be negative. Does that make sense? Good question. Okay, so really we only have like 5 minutes, so maybe we won't do the worksheet. Maybe I'll just have you give those back to me. Oh no, this is a good one. Do this one. Go. We still have 5 minutes. This is such a good one. So I just want to, Amelia, what did you do again? You did what? She said let h of x be 1 over x squared. Let g of x be x minus 2. So that's good, but you're not done. Then Amelia also said we want to find h, you said h of g of x. That is correct. Wouldn't that work? G of x into h of x, doesn't that give us this? Okay, so then Chips was really creative. Chip said what? Let h of x be x to the -2, and g of x equals x minus 2. Won't that? And then you said, which one are we plugging into which? So that would be HOG of x. I just wrote it differently that time. Right? Because then plugging that in there, wouldn't that yield this? Very creative, Chip. Awesome. Do we all get what we're doing with this? Okay, awesome. So that we'll call it quits for the day. Good job today.